Thanks for joining, everybody. Ilya, if you want to get started, other people can keep filling in, but we've got a good group here.
All right, thank you, Wendy. So good time of day to you, to wherever you are. Today we have a panel on ups and downs of cloud computing and open science. My name is Ilya Baldin. I'm the moderator for this panel. I represent the CICOE pilot, and I'm the Director for Network and Research Infrastructure at RENC at UNC Chapel Hill. And up front, I have to say, I had nothing to do with what happened at UNC in the past 2 weeks. We've made many news, so. So this topic is very challenging, fraught with kind of errors and potential pitfalls and many trade-offs. And so today we have a panel of 3 distinguished speakers who will address different parts of this area. If you could advance by 1 slide, please. Basically, you know, cloud adoption is a difficult problem for this community. Costs, capabilities, staff training, many other topics immediately come to mind. There are many practical questions that people ask regarding, you know, what is the best architecture? What are some of the best practices for the transition to the cloud? Which parts of the infrastructure make sense to transition to the cloud? Things like security. How do you do security in the cloud? Monitoring. How do you port your software to be cloud native so that it eases the transition to the cloud? All these things. And of course, there are also sort of solutions for, you know, where you don't fully commit to one approach or another, and you look at hybrid infrastructures where parts of your infrastructure resides on premises and parts resides in the cloud. And again, what's the best approach? And of course, private versus public clouds is also a big question. Next slide, please. This is also a space for interesting experiments that push the limits, and I think maybe Benedict will address this in a lot more detail. I'm just going to briefly mention that this happened in November of last year, where between IceCube and OSG, there was a kind of a cloud burst experiment that acquired basically every single GPU that AWS had, and it turns out the number is about 50,000. For about 2 hours. And this is a very interesting experiment. As you can see, you know, the number of petaflops is sky high. It's also quite challenging logistically. And, you know, there will be others, no doubt. And they will show some of the way towards, you know, what the benefits, what the trade-offs are with a cloud adoption and open science. So moving on to the next slide. As I've mentioned, we have today 3 speakers. Benedict Rydell from IceCube, University of Wisconsin, David Hancock from Jetstream, PI for Jetstream from Indiana University, and Mike Stanfield from ResearchSOC at IU. And I will, Benedict will, if you could start sharing, all I will say is that we have a poll that I'm launching right now that will run until the end of the presentations of the speakers. And please look at it. It's a multiple choice set of questions. We'd like to kind of take the temperature of this group to see which questions arise the most interest so that we can help steer the discussion within the panel. And Benedict, please go ahead.
Sure, I hope you can hear me and see my slides. So, so just briefly sort of an overview of, you know, how IceCube computing overall, I mean, as Ilya just mentioned, the cloud burst, but then also kind of the things that we have learned as sort of a large facility when using the cloud. So I'm the global computing coordinator for the IceCube Neutrino Observatory, and I've worked on the open science group before, so I'm sort of well versed in the sort of large-scale science or large-scale production, and then so we were also part of this NSF and Internet 2 initiative called Exploring Clouds for the Acceleration of Science and ECAS. So we were part of phase 1 there, and then as Ilya mentioned, we had this cloud burst experiment. We've actually done 2 so far with folks from STSC and UCSD. And we were basically able to aggregate over 51,000 GPUs across sort of three largest cloud providers. So shortly, what is IceCube? It's a neutrino detector that has been deployed in the Arctic ice shelf. There's over 5,160 detectors that are buried in the ice. There's a broad science reach, so besides sort of astrophysics and neutrino astrophysics, there's also neutrino physics, earth sciences, and particle physics in general. And overall, we're kind of following sort of the classical particle physics computing model, you know, grid computing, high throughput computing for the most part. So in ECAS, sort of we are two things are kind of scaling and experiments. So for multi-messenger astrophysics, so this is one of the things that has sort of been really in the headlines the last 2 years. It has been that you know, we need to do a lot of computing on a very small time scale, and also we know it scales the number of cores. So the cloud provides us kind of this platform of having as many cores as we want on demand. Similarly, there's experiments like other facilities like Chameleon or Jetstream that have novel or computing architectures like FPGAs and ARM, but there's other ones like TPUs that are coming that are only available through the cloud. There's also the question of, will it break kind of thing, if we transfer our workflows from OSG to, for example, Summit, will they break in that way? So what do we learn kind of, we can have this on-demand scaling. We need 40,000 cores now. There's a good ROI on the right application. It has to be CPU heavy, little data movement. There's a funding, but there's also sort of a bureaucratic overhead in terms of the university and also the funding agencies. So with the cloud burst, so 2 experiments so far. So the first one was to sort of give us everything that you have. And the second one was go efficient. So we aggregated, only 15,000, but it's the most cost-effective ones. So, we integrated 1 exaflop hour in roughly 8 hours, again, across 3 cloud providers. We can scale, and what we learn ultimately, we can scale. The cloud is expensive in the sense, if we were to replace all of IceCube computing, we would be at $50 to $100 million per year, depending on all the black holes in the cloud budgeting. And then, the data movement can blow the budget. So the networking cost for, if you have a lot of data movement, can be bigger than the compute costs. And then there's the social engineering, it's a new thing for the universities, it's a new thing for the funding agencies. And then also, you are just one of many people, and you're not necessarily the biggest person in the cloud. So that is a big thing. So you're just a fish in a big pond kind of thing. So you need somebody to advocate for you internally. So there's this cloud idea, but it's not just AWS, Azure, and Google. There's also all these business services, these project management things, human resources things. There's these data center services, so monitoring, control planes, et cetera, and all these things that have coming out of the cloud that affect us, like Kubernetes, for example, is a big one right now. Where do we see the cloud? So there's a big, the ROI, the return on investment, is really the big question. It's great for things like email, code repositories, and sort of the ancillary services. Then it really depends on scale. So if you're IceCube, Jira or Trello are just too expensive for a large group. The computing has to be CPU heavy and little data. And then, just replacing everything with the cloud is just simply too expensive. And then, of course, there's a big thing about social engineering on the funding agency level, the university level, and the cloud provider level. So something like Cloud Bank is a very good start, but, it currently has a very limited scope. So, but we need it sort of for everyone. So I'll leave the questions for later, and thank you for your attention.
Thank you, Benedict. David, I think you're next.
All right. Let me try to share my screen here. There we go. Are you guys seeing that okay?
It looks a little narrow. I don't know if it's using the full screen. Can you get any better?
It is using full screen, but let me see. Does that view any better?
To me, it looks like a phone screen, but is anybody else experiencing the same thing?
Are you running your monitor vertically?
Yes.
I do have a vertical monitor, so
That's issue. Well,
I unfortunately can't change that.
no problem. Just
So.
proceed.
All right. Well, thank you for the invitation and for the introduction. I'm David Hancock from Indiana University. So I direct our local and national high performance computing, storage, cloud resources at IU, the PI of Jetstream as well as Jetstream 2, and have played some sort of role in the national infrastructure since about 2003. I think Ilya had some great questions to start off, kind of left my mind wondering on which of them to tackle. So at any given point, I may be thinking of one of these and talking about another. So hopefully we'll be able to narrow it to the most interesting ones during the discussion. So I wanted to touch on a few aspects of Jetstream and things we've done or projects that have been involved. If you don't know what Jetstream is, it's a production cloud facility funded by the NSF. Jetstream 2 is its successor that expands the scope in terms of hardware and software and hopefully reach that will be starting up here in October, providing on-demand resources, interactive resources with emphasis on ease of use and providing a programmable environment that can adapt in the way your traditional cloud infrastructure would in targeting specific functions and platforms that you need. It's also really reached a broader impact than the initial funding in serving a large swath of institutions, PIs, users of within the Exceed ecosystem, which some of the other NSF resources are out of that, but within that portfolio, as well as a large impact into education and workforce development, things I think that are particularly apt for cloud usage. So back when we could talk about things other than COVID-19, you guys probably remember the imaging of the M87 Black Hole. This work, the cloud was essential to that, and I think provides a good case of kind of private, at least it's private to me, but it's a public resource in Jetstream and transitioning to the commercial cloud. So that is one of the things that associate professor from University of Arizona highlighted as the importance. Without having these resources like Jetstream, there might not have been a pipeline to that commercial route in working with Google to do the analysis and looking at ways to continue to refine that pipeline and kind of, as Benedict said, finding the parts of the workflow that really fit, maybe not replacing your entire workflow everywhere. Another interesting example is, we have applications and services which are not traditional high performance computing. This is a highlight from Professor Jill Irvine from the University of Oklahoma. A workflow in grabbing news articles, correlating events, being able to mine those, things that are not traditionally done in most HPC environments, but workflows that you can easily find the services and functions you need in the cloud to make those things happen. Representing more of a traditional research side in seismology, and Chad Trabon, I believe, is attendee in the virtual audience if there are questions about this project as well. But they did an evaluation in 2018 of GeoSci Cloud to look at migrating some of their infrastructure for serving seismic data into the cloud, taking a test data set, core data services, deploying those within Exceed and Jetstream specifically, as well as AWS, and comparing that with their local facility, as well as their backup data center. And had some interesting notes in terms of the ability to scale and the things that the cloud offered them with performance comparisons. And he went on to highlight some of the pros and cons, which I think have certainly shaped the future of the IRIS and UNAVCO projects, but have also helped kind of direct the future of what Jetstream 2 is becoming because of that. So some of the things that Chad highlighted to us in 2018 were deficiencies in terms of wanting more storage, different saturated storage performance at some point, things that we could well understand because we had knowledge of the system. The allocation model, which comes in terms of 1 year increments, something you don't have in the commercial cloud. So there are tensions in the way these resources are allocated, and things we hope to push with Jetstream 2. But some of the pros have led us to continue working together with these teams in terms of being able to dig into the details with them and get highly valuable direct support, things that can come at quite a cost when you start consulting or locking into a specific provider. So those are just a few of that project's thoughts, and it's not all one-sided. You have to make those evaluations. They're talking about hundreds of VMs and servers that reside in physical facilities and moving those into cloud facilities. So those decisions are different depending on your workflow. For education and workforce development, I think being able to have cloud infrastructure really enables one to take advantage of the latest techniques. This Unidata workshop at AMS all used Jupyter Hubs and Kubernetes, things that you can do in private public cloud environments that are, I think, important into getting people training that are discipline specific and in environments that are consistent across different workshops, whether that's done on your own or somebody else's systems. And just briefly to touch on some of the return on investment analysis we've done. It's not traditional ROI. We're not investing and then looking at how the returns are in a couple of years. It's ROI as a proxy, kind of looking at cost avoidance. And I think that's important to note the difference in some of the analysis. But some of this work was started by Craig Stewart as part of Exceed and his ROI analysis, and co-authored a couple papers and looked at some of the local aspects with which we hope to further publish in saying, does it make sense to invest in our local HPC resources or resources like Jetstream, and what would be the cost of doing some of these things. And so further analysis will be coming out that'll update from Big Red 2's entire lifetime, but we do have a paper there if interested, and even using some of the other estimates, like Fermi did an interesting HEP Cloud experiment a couple of years ago, yields a favorable cost for these large centralized infrastructures, but there are targeted infrastructures where it absolutely makes sense to leverage and use the commercial cloud. In terms of a couple timelines, and I'll wrap it up here. Jetstream is in its 5th year of operations and will be has requested an extension for another year. We hope to have overlap and continue to serve the community You know, we're hoping to submit some new ROI work this yet this year for our journal. So should be some updates there, and I have to acknowledge all our partners and funding agencies. So thanks for that. And looking forward to the discussion.
Thank you, David. It's an interesting point of view from a private cloud provider, essentially. Mike, I think you're next. And then just as a reminder, we have a poll running. I'll close it as soon as Mike's finished his presentation. If you could respond and kind of indicate your preferences for the topics to be discussed, we're going to use it as a kind of a guide to for further discussion for the remainder of the panel. Thank you.
Yeah, thanks, Ilya. So hello, everyone. My name is Mike Stanfield. I work at the Center for Applied Cybersecurity Research at Indiana University. As Ilya mentioned, I'm also part of the ResearchSOC project. I work on that. And then related to the cloud stuff we're going to be talking today, a lot of what I'm going to be saying kind of comes from me with my Open Science Grid Information Security Officer hat on, because that's where a lot of what I'm working on that kind of touches the cloud, like the project Benedict was referring to earlier with IceCube. That's where my experience with that is coming from. Screen. All right. So I'm going to keep my presentation is going to be kind of short because I think talking about security without talking about context of an actual problem or actual project is kind of difficult. I think the value of injecting security into here will be in the conversation we have as a group. But I did want to point out just a couple of key things that everyone really needs to be thinking about if you're thinking about evaluating the cloud for your project, migrating some of your already existing workflows, whatever. Right. The first one's sort of high level risk analysis. And if you look at my last bullet here, what I don't really want to do is talk about, the kind of typical security, fear, uncertainty, doubt, right? We're going to go in the cloud. You're going to be running on hardware that you may be adjacent to an attacker. For open science, that's kind of it's a bit less of a concern in most cases than say, if you're a Fortune 500 company trying to protect, data. That said, if you're handling any kind of restricted data, this is something you have to consider. You are going to be running in the same space as a potential adversary. You're one hypervisor ODay away from potential compromise. So with that out of the way, so I don't have to mention Rowhammer Inspector and all the nasty CPU vulnerabilities again, we'll talk about some interesting things. So cloud security challenges aren't exactly new, right? We're talking about computers, we're talking about infrastructure. We've gotten very good at virtualizing things. We know how to do this. It's not new, but we are kind of picking all of that up and moving it somewhere else where we have a little less direct control, places where old processes we may have used for administering systems go out the window as we have to adapt to these new workflows. So, and I trying to come up with something entertaining for my slides, right? Cloudy with a chance of misconfigurations. The vast majority of security vulnerabilities that I have seen, anecdotally at least, is that they are misconfigurations. It's not new ODays. It's not new vulnerabilities in your software. It is a misconfigured S3 bucket. It is a bad identity and access management profile, allowing for horizontal traverse through your virtual network in AWS. So when we talk about what are the big things we need to worry about, it sounds all a lot like what we think about when we're hosting things on-prem, but some of it is a little different, right, in terms of how we manage it. And a lot of it is actually going to be vendor specific. AWS is going to handle ingress and egress different than say, Google Cloud, right? So each of these may be a little different depending on where you go. That's, another point around the vendor lock-in that may be worth thinking about. But, inventory and patch management, you can automatically spin up, instances via your, CI/CD pipeline. How are you keeping track of all of those? You're managing secrets. You're still going to have SSH keys, API keys, potentially encryption keys, X509 certificates, blah, blah, blah. All of these things, are going out on disk. And, we need to think about them similar to how we think about them on-prem. And finally, identity management, auth in, auth z. This is a thing where a lot of times you'll see this gets brought back home. We want to host, you know, our SSO, you know, we want to use SSO, we'll stand up shibboleth on our own network, and we'll, you know, bridge it back over into the cloud. There's, I mean, so, you know, these are all things to consider. These are all things that it's really good to think of up front, right? You don't want to get halfway into, you know, re-architecting your project to go into the cloud and think, oh, how do we protect this important thing? I come from a software security background, so I think cloud, I immediately jump into software payloads, thinking about how do I build things, how do I deploy them. David mentioned Kubernetes recently. You know, a lot of what we've been working on, you know, is trying to build out the ability to use the horizontally scaling that comes with these tools like Kubernetes, you know, both using the, you know, commercial cloud, the remote cloud, but also using our local resources, right? That can help us solve those same sort of problems back at home. To make the most use of that, a lot of the times you're going to be using containers, you know, either Docker or Singularity. And containers seem great, right? I use them every day. It lets me deploy my software trivially, as opposed to standing up a whole new stack on something, you know, it's a whole new VM. You know, it solves a lot of dependency management problems that are a struggle for deploying other software. But, you know, those same things actually turn out to be kind of a foot gun, as we've seen, or as I've seen at least in some of the work that I've done on the open science grid. We've got issues around just, you know, vulnerabilities and dependencies. I pull a container image from upstream. I know nothing about it. I need to validate, you know, what is coming in that, you know, CentOS latest image, what packages are already installed, are there issues in them? Is my software installing, you know, things from a repo that may be outdated? And kind of tied to that is just container updates in general. Containers are great. You deploy them. You put that tag in the top of your Docker file that says, "I want the latest CentOS 7 image." But if you never rebuild that Docker image from that Docker file, you will end up running outdated software eventually. We actually had this happen a few months ago when a root CA certificate expired. We had replaced that in an update in a container that we were distributing, you know, months ahead of time, had tested and validated. And then the day of the expiration came, and we had people come to us and say, "Hey, we're having, you know, we're suddenly getting, you know, connection errors, right? Authentication errors, complaining about an expired certificate." It turned out we had provided the update, but everyone had actually, or, you know, certain groups hadn't actually updated those containers, hadn't rebuilt those images to pull down those latest updates. So it's something to think about. If you're containerizing your workflow, how are you going to manage those updates? How are you going to, you know, manage, you know, dependencies and make sure that you're actually managing things appropriately? This is not a new problem. And honestly, containers probably make this easier, but it doesn't mean it's something that we can ignore. And then finally, I just wanted to point out, you know, if we're on the internet, you're getting attacked, right? And this isn't meant to be some fear-mongering or statement or something. This is just the reality of the internet today. Attackers are scanning everything, every day. If you question this, you know, go hop onto shodan.io and put a host name or IP address of one of your systems in there, and, you know, see that, you know, all the ports that are open, all the software running on it has already been enumerated. It's open source intelligence. It already exists. That said, public cloud resources tend to be a juicier target, right? It's an environment that attackers understand very well, right? It's not like they've landed into your HPC center and don't know what they're looking at. They know how to spin up, you know, they know how to move and traverse through AWS. They know what user roles they're looking for. You know, there are a lot of off-the-shelf tools that already exist that have been built to facilitate this. They don't need to learn how your job scheduler works because they're going to, you know, take over your system at the, you know, administration level within the cloud. And so, like I said, this isn't meant to be scary. This is just a reality. The cool part about that is, as a result, those tools already exist. Those methodologies exist, and we can use them as well. So we've had a lot of luck, a lot of great results in the past year using, you know, off-the-shelf open source vulnerability scanners to, you know, just scan our project's internet-facing footprint. Look for vulnerabilities, find them, or misconfigurations. And honestly, most of what we found are misconfigurations. Get back to the teams that have them, get them fixed. You know, and the idea is we want to we would like to find stuff before our attackers do. So for any of the security folks in the audience, it's something to think about. If you're standing up a new Kubernetes cluster, go grab a copy of Kube Hunter and run that against it, right? That's what the bad guys are going to do. You might as well, be doing that as well. So I'm really looking forward to kind of the wider discussion. That's all I have.
Thank you, Mike. So I'm going to close the poll, and let's see. Hopefully it'll help us, let us see the results. Yes. So it's interesting that there aren't very clear winners. All topics kind of are of interest, but there are some. So number one appears to be the strategies for dealing with large scientific data sets with respect to storage and transfer costs. And I'm just wondering if perhaps Benedict or David could address, these from their perspective.
I mean, I can start. I mean, from my side, I mean, for the two cloud-based experiments, we focused on basically saying, the data is subdominant compared to what we usually do. So we made it such that it's low IO in fetching the data and like removing the data. I mean, overall, currently the big concern is, the egress charges. And that's something that Internet 2 is working on and NSF is working on in terms of, reducing those. There are, as some might know, there are sort of discounts if, the data is less than 15% of your bill, it gets waived, and et cetera, et cetera, et cetera. But ultimately, if it gets large, you are going to have a surprise bill at the end of the day. And I'm going to say it's not going to be small. I mean, you're asking. I mean, if you're not doing sort of a Monte Carlo simulation where the input is a couple numbers, the output is a couple gigabytes, it becomes extremely expensive where the network cost outstrips the computing cost. That's something that at least for large data sets, we haven't really thought about ever, because Internet 2 and ESNet and sort of the scientific networks have been there to sort of buffer the cost for us. And they're hidden, but I mean, at this point, the cloud really does strike. It gives you this, this is what your actual costs are, and X% of this are hidden from you. And it's kind of eye-opening to see, we're actually in this league of large startups in terms of computing costs and network costs and things like that when it comes to large data sets. I mean, there's a lot of variables here that also go into this.
Yeah, and I would just add, there was a interesting discussion at the workshop on next generation cloud resources last year. It was held in Princeton. You guys can find the workshop report. But one of the projects was a neuroscience project from Princeton that did a 1-year simulation in the commercial cloud, and they happen to be using Google for that. And as part of it, one of their conclusions was, well, we had to make some tough decisions, or the cost really ramped up. Like, okay, do we store this interim product for a week, 2 weeks, 3 weeks? Somebody has to pay the bill. What if we need to recompute it? So you sometimes have to think about your data differently in the commercial cloud because of the costs, which is not always a bad thing. Ultimately, what they decided was, if they were to do it again, some of the computation was more affordable than they thought, and what they would want is to have some on-prem data and be able to use that data store to transfer into the commercial cloud. disregard as much of the data as they can and pull back smaller output. So it's certainly you have to kind of shape your workflow around that sometimes to kind of optimize for it, where compute may be more expendable, especially if you're using spot instances or other things as shown in some of these experiments. So I would say those, maybe that they're not necessarily strategies, but I think things to think about in terms of institutions as a whole. I think as IU has certainly learned, it can be challenging when you get into these long-term agreements. Our institution has stored almost 3 petabytes in box and is now migrating it to another provider at immense cost after our contract went up about 1,000% from annually. So if we're not learning from those lessons, we're gonna be repeating some of these mistakes in the future.
Thank you. So actually the next question in popularity relates a little bit to this, I think. It's the question of how best to think about hybrid infrastructures, benefits of keeping CI on-prem and then, also putting some in the cloud. And of course, data still is a big problem of that. So I'm wondering, David, maybe if you could start on that as well.
Sorry, I was grabbing the workshop link as requested in chat. What was the question again?
The question was the ways to think about hybrid infrastructures, benefits of keeping some parts of the CI on-prem, but I think, it's also kind of a reflection on the previous question, which is data and data movement becomes a problem.
Yeah, I think there was also a related question, I think from NCAR, and the standardization. I think some of the advantages of hybrid infrastructure and now having projects like OpenStack is you can kind of standardize some of that private infrastructure, so you have APIs that are similar as you move between private or even commercial infrastructure that are built on the same things. Or when you're talking about interfacing with storage, specifically object storage, you can find common ground in interfacing with through things like S3 and what are common protocols. Now, you don't always get a guarantee that every aspect of every command is going to work, but core functions of the API are there. So it's not without challenges, but trying to think about that together, and also, as I think Benedict pointed out, thinking about the ways in which commercial options can give you things that you don't have locally. If you don't have mass need for FPGA or the latest accelerator, or increasingly you want to do large experiments into ARM, and you don't want to invest in those things or just can't, you would be foolish not to try to take advantage of that and say, how does this work in terms of performance? How does it work in my workflow? And does it make sense? Do I have enough usage to run some of this in-house and combine the two? So that's kind of how I've thought about it as sort of a provider of central resources and external ones as well.
So before we go to other panelists for this question, if you could answer a question from Brian Dobbins from NCAR, it was earlier.
Yeah, so if you didn't see it in the chat, does he, I was asking about, does Jetstream offer standardized ways to provide, on-premise clouds? That is something, maybe I wouldn't say standardized, but just more consistent to say, well, here's the infrastructure we're going to roll out, and it's going to work for everybody. You can do the same exact thing as us. Is certainly a little naive on our part, but I think the core functions and services that are part of Jetstream are part of what most people would build in terms of their own private cloud. We're providing our scripts, configuration, management techniques openly. We have done that as part of Jetstream, as part of the future environment, Jetstream 2. We hope to make this a little easier and more consistent for people to say, oh, we could adopt some of these scripts, use them. You can certainly use the same projects and services versions, in willing to partner on the educational aspects as we have with many institutions, and Exceed has done that as well, and having a group where they've helped deploy clusters at sites before, and partnering with them to deploy some of these cloud resources at sites is something they've helped with in the past. So we hope to continue that work, because a lot of it is in that knowledge transfer. You can't just necessarily run a script and say, okay, now I'm going to understand what every error is going to be that you're going to encounter. So.
And there was a comment from one of the attendees suggesting that perhaps some configuration management tools like Terraform can help with both, I think, hybridization as well as standardization of configurations and everything.
Yeah, that's absolutely true. So you can use that today to go across providers, and it is challenging to get things into that language. But if you're thinking, well, I don't want to be locked into AWS or Google or even Jetstream, I want to be able to run this on multiple providers. Using something like that can be a very good idea.
Benedict, I'm wondering if, from perspective of IceCube, you have any comments on the kind of hybrid approach to infrastructure.
Sure. So, I mean, from our side, there is sort of this, how should I put this, this weird dichotomy where some things just make absolute sense. So, for example, we need fast turnover for a very specific workload, and the cloud is perfect for that. But also this application is, compute heavy, doesn't need a lot of input data. I mean, it's the perfect thing. And then there is sort of the next category, which is sort of the stuff that we need to run for as sort of a large facility. So email, business, document management, etc. And, there, for example, Microsoft and Google, they provide it for free. So, what's cheaper than free kind of thing. I mean, it reduces our costs ultimately. But then, when you go then to something like, some project management tools, call it Trello, call it Jira, and you have 300 people, that just blows the budget again. And it's very, very hard you have to be very careful, and, ultimately is, how many users are actually going to need this? How many users do you have, and what's the cost per user? I mean, for example, Slack, as an example, has, it's 85%, or something around 85%, a discount for academic, but they're a rarity in that sense. Most others, they give you 50 or something like that, but you really need, 80, 90% discount to make it worthwhile in terms of sort of business services. And I mean, then, the sort of the third category is sort of the general compute. I mean, IceCube now, we run about 10 petabytes of storage, and 10 petabytes of storage in the cloud is just, unaffordable. And then on top of all of this comes sort of this weird issue in culture where, currently every university has their own overhead rules on cloud. So, for example, the University of California system has a big advantage right now because they don't have overhead, while UW in Wisconsin has overhead. There's also this weird, inverted thought process that, if I buy a server, I pay once, even though for the university, it's one of the most expensive things I can buy because, you know, power, cooling, footprint, I mean, is exceedingly expensive. But, you know, from my side, I pay $5,000, you know, and then run the thing for 6 years, and it costs me the same. And then per year, I actually, you know, I spend less on compute per year than I do as I run the server kind of thing as I would in the cloud. Do I get, you know, especially now with Moore's law and the NARD scaling kind of leveling off, and, you know, you're only getting 10-20% per generation of CPU. Okay, I saved 50% of my compute cost and I'm 20% slower. Great. From an ROI standpoint, it's still great. Now, if that, you know, is going to change at some point, then the cloud again becomes this very attractive thing. But currently, with sort of this weird inverted overhead rules and funding aspect of it, I don't see the cloud ever really being able to compete, especially with the HPC centers, because, I mean, they're not going to give you the InfiniBand 400 gig network any cheaper than, you know, than a DOE or NSF will give it to you.
Thank you. So next question in popularity, which surprisingly wasn't first, but is still fairly close, is security. Security implications for hybrid infrastructures, also for cloud infrastructures, including identity management and others. Mike, I think it's in your, definitely in your court, but keep in mind we only have about 10 minutes left, and I realize
yeah, so with 10 minutes left, I mean, is there any specific, I mean, that's just the broad side possible. So I'm curious if anyone in the chat has like a more specific question. I mean, otherwise, and while maybe you're thinking and typing, I will just say, I mean, back to kind of the hybrid approach, I mean, it makes a lot of sense if you have some bit of infrastructure that is more sensitive than others, right? If you have some processes or some software, or, you know, you want to handle identity management on your own end, you don't want to put secrets in the cloud, those sort of things staying on-prem make a lot of sense. So there's a question. Concerns around federation and security. Federation and security, I mean, that's kind of the open question of grid computing still, right? Is we have this federation of systems talking to each other, and how do we secure that? How do we protect that? And in my mind, you know, the public cloud especially is simply another site, another grid site that I am talking to in that regard, right? It is there. You know, someone is managing it. We are going to talk to it, and we are pulling it into our federation with the same sort of controls that we would always do. And I mean, they really come down to you know, managing the access of, you know, who has access to do admin work in your cloud, right? That person's account is critical. Per person or people's accounts are critical, right? Making sure that you've done everything you can to protect them, which is both, you know, user training, both in security and their jobs, you know, enabling multi-factor authentication, you know, SSH keys, you know, things like that. In terms of like actual, say, like in terms of like compute or, you know, application authorization, authentication, federation, right? It kind of comes down to, I mean, what you're comfortable with. When I look at what OSG has been doing, you know, traditionally, right, with X509 for identifying users, identifying services, machines, you know, we're in the process of uprooting all of that to move, you know, into the magical future land of, you know, JWT-based, you know, authorization and authentication. And then, you know, while it's fundamentally the same in terms of I'm still cryptographically signing something to identify a person, right? It is a new technology stack, and in some ways it is a much better fit for what we have here. When we're talking about, you know, essentially ephemeral, you know, immutable instances out of containers, or, you know, that I'm spinning up in the cloud, being able to move to a more ephemeral, not long-term token-based authentication is very useful. So, you know, the death of X509, you know, could come sooner. as it were. I realize that's kind of a whirlwind around the idea of like federation, but I guess we are kind of running out of time. I'd be super happy to continue that conversation offline though, if you are interested.
I think there are a couple more comments.
Yes. So there's this interesting thing, this question from Inkar. This is, so full disclosure, I come from a very, or from industry. I used to work for a credit card company. I'm used to everything as being secret, and coming into open science has been a revelation, right? We had meeting notes on Google Drive that anyone could go read, and I found that terrifying, right? They had host names and things, and I'm like, this is just super secret, right? And so adjusting security to that, you're right, is difficult, right? How do we increase interaction? How do we share information? And how do we protect it at the same time, right? I kind of disagree on the decrease based on security, right? It is true. We do ask things sometimes. My home institution forces me to log in and out of Google Drive, you know, every 24 hours. Without fail, I will be kicked out. It is a terrible user experience, but it's security somehow, right? I think it's really important, is at least for me as a security practitioner, to think it's not about remembering the use case, remembering the user, right? Our job is to enable open science. Part of that enablement is protecting our resources, is protecting, you know, taxpayer investment in it, the government's investment in these resources, our institutions, all the hard work that people have done. So I mean, I agree, it's difficult. I don't have a magic answer. Each problem is unique, right? And finding that trade-off between risk and actually doing science is important. So once again, it kind of just comes back to we need to do a risk assessment. We need to understand what we're trying to protect, what we're really trying to do, and then, you know, find the right part of the dial, where to tune the dial, essentially.
So as a security practitioner, what would you say is the biggest difference with security in the cloud versus on-prem?
Well, the biggest difference. The biggest difference is if you lose control, right? If one of your admins gets popped and someone takes over your setup in AWS, and, you know, if it's your local cluster or whatever, I mean, you can literally call someone and have them turn it off. I mean, you have actual physical control over the hardware. You have a place to go. Sorry, I saw the hysterical. I hope you're talking about the cat and not my argument, but. And whereas when you're in the cloud, you're at the mercy of the cloud. If you got cut out of things, you're going to have to get a hold of support. How good's your support contract? How good, you know, what kind of relationship do you have there? So for me, that's the kind of the thing that keeps me up at night. And in terms of other things, everything else is you know, essentially a software problem, you know, a networking problem. We can solve those. We have controls, but that kind of loss of actual physical control of those systems is, you know, something to think about.
How about scale? Generally, we go to cloud for scale. Does that enter into the thinking?
So scaling security is typically hard, and typically not a thing that we're going to spend a lot of money on, right? A lot of our projects are running with minimal, you know, 1 FTE maybe security teams, right? So to scale that up, I mean, that is something that the security side really has to work on. Security has to be a partner. We have to be able to work with our operational teams, understand their infrastructure, what systems they have, you know, how they have them configured. But it's not, in order to scale ourselves, it's, you know, kind of comes back to my last slide. It's building out that tooling. It's building out that automation. It's building out these systems to use these tools to, you know, stretch ourselves as far as we can. Like I said, for OSG, we've got, you know, quite a bit of internet-facing infrastructure hosted across several universities and public clouds. You know, 10 years ago, probably, like even just scanning that would have been impossible. But we've been able to, you know, also scale out our, you know, security infrastructure to manage that kind of work, to try to keep up. So, I mean, yes, the scaling is always going to be a challenge, but it's going to be a challenge across the board. The beauty of that, though, is it lets us do a lot with very limited resources, which is, you know, very useful for the kind of work we all do.
Cool, great, thank you. So I'd like to thank all the panelists in participating. I think this has been very, very interesting. I can clearly see there are more questions from the attendees. I think you can continue engaging with the panelists through Slack. Hopefully all of you are on it. And thank you for attending. I think, Wendy, I'm handing this back to you.
Thank you, panelists. And Ilya, thank you.